Okay. So in the previous lecture, we've seen that the one-dimensional wave equation and the classification of second order PD. Okay. So this is the classification of second order partial differential equation. Okay, where L is equal to R into d2 by dx square plus s into d2 by dx dy plus t into d2 by dy square. Okay, this is the differential operator. Okay, by suitable change of the independent variable xy to zeta, sorry, xi, this is the symbol of xi. Okay, xi and eta, the given partial differential equation into one of the following canonical form. Okay, these are the three canonical forms. Okay, now the next result is the classification of second order PD. Okay, second order semi-linear partial differential equation into canonical forms on the basis of s square minus 4rt. Okay, look at here. The next result is which classify the second order partial differential equation. Classify the second order semi-linear partial differential equation into the canonical form on the basis of s square minus 4rt. Okay, is greater than 0. S square minus 4rt, which is less than 0, and s square minus 4rt is equal to 0. Okay, by using this discriminant, we have to know the second order semi-linear partial differential equation, either it is hyperbolic, parabolic, or elliptical canonical form. Okay, let's look at this, the result solution. We know that the second order semi-linear partial differential equation, second order semi-linear partial differential equation is given by LU. Okay, L is the differential operator and U is the dependent variable on xy plus G of x, y, u, ux and uy, which is equal to 0. Give it as an equation number 1, where that L is differential operator, which is equal to R into d2 by dx square, dou x square, plus S into dou 2 by dou x dou y. Okay, plus T into dou 2 by dou y square. Okay, so now we have to change the independent variable xy to zeta and xi and eta. Okay, we change the independent variables x and y to that xi and eta by means of the transformation that xi is the function of x and y. Okay, xi is the function of x and y, and eta is also function of x and y, such that the Jacobian of xi and eta with respect to xy is not equal to 0. What is the meaning of this one? Jacobian of xi and eta with respect to xy is not equal to 0. It means that in the function xi, the presence of x and y explicitly. ओके, म्हणजे या तुमच्या झाय आणि झिटामध्ये काय एक्स आणि वाय हे फंक्शन्स हे व्हेरिएबल्स आहेत एक्सप्लिसिटली. ओके, म्हणजे झाय आणि झिटामध्ये एक्स हा अब्सेंट नाहीये किंवा वाय हा अब्सेंट नाहीये, दोन्हीही व्हेरिएबल्स आहेत. ओके, नाव म्हणजे इथं काय झालं तुमचं, आता यू हा तुमचा डिपेंडेंट व्हेरिएबल, त्याच्यामध्ये तुमचा इंडिपेंडेंट व्हेरिएबल काय झाला, झाय अँड eta. Now xi is the function of x and y, and eta is the function of x and y. ओके, हे कशासाठी लिहिलं की आता डिफरन्शिएट पार्शियल विथ रिस्पेक्ट करताना हे तुम्हाला लागणार आहे पुढे. ओके, सो व्हॉट इज द मीनिंग ऑफ दिस वन, xi x into eta y minus eta x into xi y is not equal to 0. Okay, now we have to find ux uy. Now we find what is the ux, differentiate with respect to u with respect to x, but what is u? U is the function of zeta and eta, and zeta, sorry, xi and eta, and xi and eta are the functions of xy. Okay, so that's why first that differentiate u with respect to xi, and xi is the function of x plus, okay, u is the function of eta, and eta is the function of x. So this is the ux. This is the equation number 1. Okay, now second number, differentiate u with respect to y. U is the function of xi, and xi is the function of y plus, okay, plus u is the function of eta, and eta is the function of y. ओके, पहा पुन्हा डिफरन्शिएट करताना यू एक्स एक्स काढताना पुन्हा तुमचं वादकाही निकालावं लागेल. थर्ड नंबर, फाइंड द वैल्यू ऑफ u x x. Okay, now this is the u xi. Now u xi is the function of first one xi, and xi is the function of x. Okay, so here to derivative this ux with respect to x, use here u below. This is u and this is v. Okay, so first derivative of first, look at here, u is the function of xi. Okay, sorry, u xi is the function of xi, and xi is the function of x plus u xi is the function of eta. Okay, then eta is the function of x. Derivative of first and second one is as it is, zeta x. Okay, plus now first as it is, u of xi, u xi into derivative of this one is xi x x plus, now again here use u below. Okay, in the bracket, derivative of first, u eta is the function of xi, and xi is the function of x plus u eta is the function of eta, then eta is the function of x. Okay, derivative first and second is as it is here. Okay, eta of x plus u eta as it is, eta double x. Okay, समझते? Any doubt? So this is the derivative of ux with respect to x, u double x. Okay, so after simplification we get this one, uxx is equal to u zeta zeta, sorry, u xi xi into this one is zeta x square plus 2 u xi eta into xi x into eta x plus u eta eta into eta x square plus, okay, now this is u xi and xi double x plus this is u eta into eta double x. Okay, after the multiplying the u xi x and eta x in the bracket. Okay, now similarly we have to find the value of u y y. Okay, differentiate second uy with respect to y. Okay, we get this one. In place of x here we get y. Here the zeta y square, here the eta x square. Okay, जिथे जिथे x आहे तिथे काय मिळेल आपल्याला फक्त y मिळेल. Okay, so this is equal to uy, y is equal to u zeta zeta xi xi into xi y square. Okay, plus 2 into u psi eta into psi y into eta y plus u eta into this eta y square plus u of psi into psi of y into y plus u of eta into eta yy, u eta into eta yy. Okay, so this is the value of uyy. Now fifth one, differentiate x ux with respect to y. This one, first one. Okay, the ux y ची व्हॅल्यू काढायची आपल्याला. So differentiate first with respect to y. Okay, now इथे काय येणार तुमचा u विरुद्ध येईल. ओके, इथे फर्स्ट आणि सेकंड मध्ये इथे तुमचा u इंटू v वापरायचा आणि इथे u इंटू v वापरायचा. ओके, look at the value of u zeta y is equal to in the bracket u psi psi into okay psi of psi y plus u psi eta into eta y. This is the first derivative of first and second as it is psi x. Okay, plus second as it is, first as it is, derivative of second psi xy. Okay, plus now in the second one use u will here. Okay, this one is u, this one is with b. Okay, now derivative of first one u eta xi, and xi is the function of y plus u eta is the function of eta and eta is the function of y. And second as it is eta x plus first as it is and derivative of second eta x y. Okay, after simplification we get uxy is equal to multiply this zeta x and eta x, xi x and eta x in the bracket. We will get u of psi into psi x into psi y plus u of psi eta into bracket. Okay, psi x eta y plus eta x psi y plus u eta into eta x eta y plus u psi into psi xy plus u of eta eta xy. So this is the value of uxy. Okay, डिफरेंशिएट करताना व्यवस्थित डिफरेंशिएट करा. फक्त हा ब्रॅकेट तिथे सिम्प्लिफाय केलेला. ओके, फर्स्ट टाइम करताना अवघड वाटेल पण हे सगळं इथून पुढे सिम्बॉल असंच जाईल. Okay, so this is the value of uxx, uyy and uxy. Put all the values of uxx, uyy and uxy in the operator lu. Okay, this one d2 dou 2y by dou x square dou 2y by dou 2 by dou x dou y. Okay, this one lu. Putting all these values in an operator lu. Okay, we have. Okay, so what is lu? Wait a minute. LU is nothing but what? L into U is equal to R into UXX, okay, plus S into UXY plus T into UYY. Okay, putting this all these values in this equation. So we get, look at here, neat lecture. LU is equal to R into bracket. Now what is the value of UXX? U psi psi into psi x square plus 2 into U psi eta into psi x into eta x plus U eta eta into eta x square plus U psi into psi U psi psi, wait a minute, U psi psi plus psi of xx. Okay, now you do psi U psi into psi xx plus U eta into eta of xx. Okay, this is R into this one plus now S into uxy. What is the value of uxy here? This one. Okay, हा तुमचा uxx ठेवलाय ना आता. Okay, आता value कशी ठेवलाय? uxx. Now put the value of S into uxy. This one. So this is u psi psi into psi x psi y plus u psi eta into psi x eta y plus eta x psi y. Okay, plus u eta eta into eta x into eta y plus u psi into psi x psi y, sorry, psi xy. Okay, plus u eta eta xy. Okay, this is the value of S and plus the value of uyy. Okay, u psi psi into psi y square plus 2 into इथे जिथे जिथे x आहे ना तिथे y येईल. Okay, 2 u psi eta into psi y eta y plus u of eta eta into eta y square plus u psi into psi y plus u of eta into eta y. Okay, so this is the value of L into u. Okay, R into uxx plus S into uxy plus T into uyy. Okay, now taking this common, u zeta zeta common. Okay, in the next taking common this one, u psi psi, okay, into bracket R into psi x square plus psi x into psi y plus, okay, yes, okay, x into this one and T into square. Okay, plus now taking common this one, u psi theta into the bracket. Look at here, 2 into R into psi x into psi x. Okay, psi x into eta x plus s into bracket psi x into ny eta y, sorry, plus eta sorry, xi y into theta x. Okay, bracket square plus t into xi y and eta y. Okay, now plus, now taking u eta eta common, this one आता काय कॉमन काढले u eta eta हा तुमचा कॉमन काढले. ओके, now taking u eta eta common in the bracket, what will remain? R into eta x square plus s into eta x eta y plus p into eta y square. ओके, प्लस बाकीचे राहिले असे आर कॉमन घेऊ, zeta u of xi xi xx plus u eta into eta xx into r plus s into bracket u xi into xi of xy plus u eta into eta xy. Okay, plus t into u xi into xi yy plus u eta into eta yy. Okay, after simplification we get this step. Okay, खूप किचकट आहेत स्टेप पण करावे लागतील आता तुम्हाला. Okay, this is the value of L into U, differential operator on U. Now using this LU in equation 1, using this L into U operator, okay, the L operator on U in equation number 1. Which one equation? This one. Okay, so we get U of psi into A is the function of psi x psi y, okay, plus 2 into u psi eta, okay, into B is the function of psi x eta x psi y and eta y. Okay, plus u is the function of eta eta into A is the function of eta x eta y, okay, which is equal to g of psi eta u psi and u eta. Look at it. Okay, तुमचा हा u जायचा a म्हणजे काय तुमचा a of xi eta xi y, this one is our a of this function. Okay, what is b? This one is our b, function of xi x eta x xi y eta y here. Okay, and u eta eta into a eta x eta y, this one is again your function of eta x eta y. Okay, and all other three things are function of zeta eta u zeta and u xi and u eta. Sorry. Okay, this one, this is our g. Okay, where a of xi eta and sorry xi x is there, x and xi y is r into xi x square plus s into xi x xi y plus p into psi y square. Okay, ह्याला इक्वेशन नंबर 2 म्हणा, इक्वेशन नंबर 3 म्हणा. A is the function of eta x eta y. Okay, हा तुमचा eta x eta y हा फंक्शन काय असेल, this one. हा तुमचा जो आहे की नाही वेक्टर. ओके, r into eta x square plus yes into eta x eta y plus t into eta y square. Okay, give it as equation number 4. And the b is the function of psi x, eta x, psi y, and eta y is equal to r into psi x, eta x plus yes divided by 2. Okay, after simplification this one बीटा. ओके, हे सॉल्व केल्यानंतर काय येईल, बी तुमचा हा येईल. ओके, एस डिवाइडेड बाय 2 इनटू ब्रॅकेट psi x eta y plus psi y eta x plus t into bracket psi y eta y. Give it as equation number 5. This is the value of all the three functions. Okay, now the problem is to determine the xi and eta. Okay, the next one. Now the problem is to determine psi and eta so that equation 2, okay, this one, equation number 2 takes its simplest possible form. Okay, so that the equation 2 takes its simplest possible form. Okay, so this equation will reduce to its simplest possible form okay if the discriminant s square minus 4rt, okay, s square minus 4rt of the quadratic equation r lambda square plus less lambda plus t is equal to 0. Give it as equation number 6. Is positive, negative, or 0. Okay, now look at here the case number 1. What is the case number 1? S square minus 4rt is positive, that is greater than 0. Okay, so thus the equation 6 has, okay, if s square minus 4rt, this is the quadratic equation. Okay, if एखाद्या क्वाड्रॅटिक इक्वेशन मध्ये बी स्क्वेअर मायनस 4ac जर ग्रेटर दॅन 0 असेल तर रूट्स कसे असतात त्याचे, डिस्टिंक्ट अँड रियल. ओके, सो इन दिस इक्वेशन, इक्वेशन नंबर 6 has real and distinct roots. Okay, in the case 1 we assume that s square minus 4rt is greater than 0. Hence the quadratic equation 6 has the roots real and distinct roots. Suppose say they are lambda 1 and lambda 2. Okay, the two roots are real and distinct roots. Now take and choose the independent variable. Okay, which one? Xi and zeta. Okay, xi and eta, such that xi of x, derivative of x, derivative of xi with respect to x is lambda 1 into xi y. असा यायला पाहिजे, असे चूज करायचे. ओके, and eta x is equal to lambda 2 into eta y. Give it as an equation number 7. choose the independent variable psi and eta such that this condition holds. Equation number 7. Okay, these are the first order semi-linear partial differential equation. Okay, these are the what? First order semi-linear partial differential equation. These are the first order semi-linear partial differential equation. And for psi and eta, solving equation 7. Okay, after equation 7 by Lagrange's method. By Lagrange's method, we have, okay, solve equation 7 by Lagrange's method. What we have then? This is psi x minus lambda 1 psi y is equal to 0. So what we have then? Dx upon 1 is the coefficient of 1. Okay, is equal to dy upon minus lambda 1 is equal to, what is the dependent variable? Not z here, psi. Okay, d psi by 0. Okay, consider the first two ratios. Consider these two ratios. First two ratios. Okay, what we get then? Dx upon dy. Dx upon 1 is equal to dx upon 1 is equal to dy upon minus lambda 1. That implies dy by dx plus lambda 1 is equal to 0. Okay, that implies dy by dx is equal to plus lambda 1 of xy is equal to 0. Okay, lambda 1 is the rule, so this is the function of xy. Okay, so after solving, we get differentiating with, we get what? F1 is the function of xy is equal to c1. Okay, similarly, solving the second equation. For lambda 2, what we get? Dx upon 1 is equal to dy upon minus lambda 2. Okay, for second rule is equal to d psi upon 0. Okay, again, we considering the first two ratios. What we get? That implies dy by dx plus lambda 2 of xy is equal to 0. And after integrating, we get f is the function of f2 is the function of xy equal to c2. Okay, now the select that psi is equal to f1 of xy. Okay, असं assume केलं, wait a minute, and eta is the function of f2 of xy. जर तुम्ही झाय हा फंक्शन f1 आणि eta हा तुमचा फंक्शन अज्यूम केला तरच मग हे कंडिशन काय होतील? होल्ड होतील. विच वन? दिस वन. ओके, ह्याच्यावरूनच आपण हे केलं ना, ऑप्टेन केलं झाय आणि eta. Okay, so if we consider the xi and eta is f1 and f2, then it satisfies equation number 7. Okay, now consider next step. Consider for this choice of xi and eta, this choice of xi and eta, what we get? This one, first function a of xi x psi y is equal to, what is the value of this one? A psi x psi y, this one. Okay, equation number 3. Look at here, equation number 3. Okay, right? R into psi x square plus s into psi x psi y. Okay, plus t into xi square xi y square. This is equation number third. Now putting the value of this one, r into what is the x? Lambda 1 from equation number 7. Xi x की value क्या है? Lambda 1 into xi y. Okay, put here that value. Lambda 1 square into xi y square plus this one is yes into lambda 1 into value of this one xi y. Okay, so xi y into xi y square. Okay, plus a into xi y square. Now taking xi y common, xi y square in the bracket r into lambda 1 square plus s into lambda 1 plus t. Okay, so this is equal to psi y square. Now, if lambda 1 is the root of that quadratic equation, we get the value of this one is 0. Okay, why? Since lambda 1 is the root of r lambda square plus s lambda plus t is equal to 0. Okay, so this implies a of psi x psi y is equal to 0. Okay, similarly for this one, equation 4 is also equal to 0, a of psi eta x and eta y. Okay, similarly from equation 4, what is equation 4? A of eta x and eta y, we get 0. Okay, thus putting the value of these two equations in equation number 2, thus equation 2 becomes what is equation 2? Look at it. This one, हा तुमचा काय येईल 0 येईल, हा काय येईल 0. मग काय राहिला तुमचा फक्त आणि हा. Okay, so what will remain here? Equation 2 becomes 2 into b into, okay, this is the function of what? Psi x psi y eta x eta y. Okay, into the u of zeta eta. Okay, is equal to g of psi eta u psi and u eta. Okay, so that implies value of u psi eta is equal to g upon this 2 in upon g upon 2 into this b. Okay, this function. Okay, so that implies at the last we get u of psi eta is the function. हा function काय आहे तुमचा? Phi of, हा तुमचा total function कशात येईल? Phi is the function of psi eta u, okay, u psi and u eta. Okay, आणि हा तुमचा काय होता? Look at here, u psi eta is equal to phi of this one. In the last lecture we seen that u psi is the function of this one, zeta eta u zeta u eta, u psi and u eta. It's called as hyperbolic canonical form. So which is the simplest possible form? Which is the simplest possible form of second order partial differential equation. Okay, and this is called the hyperbolic canonical form of equation 1. provided s square minus 4rt is greater than 0. मग तुम्हाला क्वेश्चन काय विचारतात, एखादा पार्शियल डिफरन्शियल इक्वेशन देतात, सेकंड ऑर्डर इक्वेशन, मग तुम्ही ते हायपरबोलिक आहे का पॅराबोलिक आहे, ओके, हे तुम्हाला सांगायचं. हायपरबोलिक आहे, पॅराबोलिक आहे का इलिप्टिकल आहे. Okay, so you how to find the value of s, r and t. If s square minus 4rt is greater than 0, then the given partial differential equation is in hyperbolic form. Okay, if the s square minus 4rt which is less than 0, तो काय असतो, पॅराबोलिक फॉर्म असतो. ओके, s square minus 4rt is equal to 0 असेल तर तो कशात येतो, पॅराबोलिक फॉर्म. इफ एन s square minus 4rt is less than 0 असेल तर तो इलिप्टिकल फॉर्म मध्ये असतो. ओके, आता सेकंड केस मध्ये काय पाहिजे आपल्याला, इन सेकंड केस वी हॅव टू प्रूव इफ s square minus 4rt is equal to 0, then the canonical form is parabolic. Okay, now in the case second, if suppose s square minus 4rt is equal to 0, thus the equation 6 has जर एखाद्या क्वाड्रॅटिक इक्वेशनचे डिस्क्रिमिनंट इक्वल टू 0 असेल तर रूट्स कसे असतात त्याचे, हे तरी माहिती पाहिजे. if s square minus 4rt, if b square minus 4ac is equal to 0, एखाद्या ax square plus bx plus c is equal to 0, in this quadratic form is the quadratic equation. If b square minus 4ac is equal to 0, then what is the nature of that roots? इयत्ता 8वी 9वी आहे, 8वीच्या पुस्तकात.
रियल एंड इक्वल
आहे का काय, रूट्स आर करेक्ट आहे, रियल एंड इक्वल रूट्स. ओके, say that root is lambda. Okay, is repeated 2 times. Okay, repeated root of equation 6. Okay, now select the variable xi. Select variable such that psi of x, okay, psi x is equal to lambda into psi y. Okay, then by above procedure, okay, इक्वेशन केस 1 मध्ये केलेलं, इथं काय रिझ्यूम केलं आपण, इक्वेशन नंबर 6. ओके, इथं झाय 1 झाय 2 लॅम्बडा 1 लॅम्बडा 2 नाही येणार, इथे एकच असल्यामुळे काय येणार, लॅम्बडा येईल. ओके, so psi x is equal to lambda into psi y by above procedure. This is the differential equation of order 1. Okay, from this equation we get the value of psi is equal to the function f1 of x y. Okay, where this procedure पाहिजे f1 of x y is equal to what, c1. Okay, is the solution of psi x is equal to lambda into psi y. Okay, that is dy by dx plus lambda of xy is equal to 0. Okay, the solution of this one. Now then select the eta has any arbitrary function, independent of psi such that a of eta x eta y is not equal to 0. त्या केस मध्ये काय केलं होतं आपण, साय एक्स इज इक्वल टू लॅम्बडा 1 इंटू झाय वाय. ओके, इटा एक्स इज इक्वल टू लॅम्बडा 2. तर तुमचं लॅम्बडा 2 नाही आहे. ओके, सो आपण लॅम्बडा ह्याच्यावरून तुम्हाला इटा काढताच येणार नाही. ओके, एफ ऑफ एक्स. सो so consider select the eta has any arbitrary function independent on xi such that that function a of eta x eta y is not equal to 0, but by the choice of xi we have, आपल्याकडे ह्याचा चॉईस आहे झायचा. ओके, दिस वन. ओके, हा तुमचा चॉईस आहे झायचा तुमचा. ओके, so we have a of xi x xi y. We get this one is 0. Okay, now putting the a of xi x xi y in equation number 2. Okay, equation 2 so एकदम वर आला होता. Yes, in equation 2 put this value is 0 इकडे. इथे फक्त तुमचा काय होईल, हा 0 होईल. ओके, हे 3 टर्म्स असेच राहतील. So now it is easy to verify that. Easy to verify that. Okay, a is the function of psi x psi y into a is the function of eta x eta y minus b square. ओके, हे का कन्सिडर केलं सांगेन मी तुम्हाला नंतर. बीटा b square of psi x psi y eta x eta y. ओके, तर हे आपण कॅल्क्युलेशन केलं तर ह्याची व्हॅल्यू येते 4rt minus s square divided by t into this one psi x eta y minus psi y eta x square. ओके, जर आपण हे कन्सिडर केलं आणि हे कॅल्क्युलेशन केलं तर व्हॅल्यू काय येते त्याची, दिस वन 4rt minus s square divided by 4 into xi x eta y minus xi y eta x. ह्याचं प्रूफ आपण नेक्स्ट लेक्चरला बघूया. ह्याचं पण प्रूफ आहे आपल्याकडे, नेक्स्ट थेरम आहे. ओके, सो फ्रॉम दिस we observe that now by putting the value of this one here. Okay, so we get तुमच्याकडे काय s square minus 4rt याची व्हॅल्यू काय येते तुमची 0 इकडे. ओके, s square minus 4rt or rt minus 4rt minus s square, value of x1 is 0. so here we get, आणि हा तुमच्याकडे काय 0, हा 0. okay, so at last we get b is the function of psi x psi y eta x eta y is equal to 0. Okay, with this choice, we observe that equation number 2 becomes put the value of this one in equation number 2. Okay, so at last we get a is the function of psi x eta y into, okay, तुमचा b पण काय झाला 0 आणि हा पण काय झाला 0. put this value in equation number 2, which one here. ओके, मग तुमचा हा पण 0 आहे. ओके, हा b आला तुमचा 0. राहिला काय तुमच्या इथे a into eta x eta y into u eta into I is equal to g. Okay, So A is the function of eta x, eta y into u eta eta is equal to g is the function of xi eta u u xi and u eta. That implies u eta eta is equal to that g is the function of this one and a is the function of this one, g upon a. Okay, so that at last we get u is the function of u eta eta is equal to, okay, the g upon a is nothing but 5. Give save. Okay, g upon a is equal to 5. That is the function of xi eta u u xi and u eta. Okay, which is the standard, which is the standard parabolic canonical form of equation 1, partial differential equation second order. S square minus 4rt is equal to 0. Okay, in the last lecture we seen that. Okay, look at it in the classification of second order partial differential equation. This one. U eta eta is the function of xi eta u xi and u eta. Okay, which is called as parabolic canonical form. Hence, if s square minus 4rt is equal to 0, then the given partial differential equation, second order partial differential equation, semi-linear, okay, is in the parabolic form. Okay, provided s square minus 4rt is equal to 0. Okay, and in case number third, if s square minus 4rt is less than 0, okay, the given equation, if s square minus 4rt is less than 0, then given second order partial differential equation is in the elliptical form. Okay, we will see this in the next lecture. Okay, now tell me, in the if the discriminant of the quadratic equation ax square plus bx plus c, if b square minus 4ac is less than 0, then what is the nature of that roots?
Not real.
Not real,
Imaginary.
that is complex,
Imaginary.
imaginary. Okay, so that we'll see in the next lecture. ओके, हे तुम्हाला समजायला अवघड असेल, यूज इटा यूज हा यू इटा वगैरे, पण एक दोनदा वाचल्यानंतरच हे समजेल. ओके, प्युअरली कॅल्क्युलेशन पार्ट आहे. ओके, एनी डाउट अप टू हियर? वेट अ मिनिट. वेट अ मिनिट. ओके, एकदा एक्झाम्पल घेतल्यानंतर मग समजेल तुम्हाला दिलेलं पार्शियल डिफरन्शियल इक्वेशन कसं आहे. ओके, ह्यांचं एक्झाम्पल कसे असतात, द गिवन पार्शियल डिफरन्शियल इक्वेशन इनटू कॅनॉनिकल फॉर्म. ओके, एखादं डिफरन्शियल इक्वेशन घेतात सेकंड ऑर्डर आणि त्याला कॅनॉनिकल फॉर्म मध्ये कन्वर्ट करायचं. ओके, एकदा एक्झाम्पल घेतल्यानंतर व्यवस्थित समजेल. ओके, and the case third we will see in the next lecture. Okay, any doubt you can ask, otherwise you can leave. Okay, thank you for the attention.
Thank you, sir.